When we reason about categories, we often visualize a category as a directed graph, where objects are drawn as vertices and morphisms as edges. For example, here is a category of 3 objects. You can see that for each vertex there is an identity arrow, and whenever there is a path from one vertex to another, there is a direct edge representing the composite morphism. Usually, we won't draw identity morphisms and composite morphisms. Their existence is implied when we say that a diagram is meant to represent a category. There is a good reason we use this shorthand. For instance, consider this category of one object. F is a non-identity morphism from A to A, which means we can generate infinitely many potentially unique morphisms by composing F with itself, so we can't draw them all. Now let's turn our attention to the relationship between some morphisms in a category. This triangle of morphisms is set to commute if and only if the 2 paths from A to C are equal. Similarly, this square of morphisms is set to commute if and only if the 2 paths from A to D are equal. Lastly, suppose squares ABCD and BEDF commute. Then the rectangle they form, which is AECF, commutes too. This is because we know from commutativity of the individual squares that x to m to n equals x to y to z. But composition is associative, so x to y to z equals u to v to z. So you see that all paths from A to F are equal.